been helpful. So
Sure.
yeah, I've been in the monitoring space for a while. I wrote 15 plus years, but I think it's more than that. I just didn't stop counting at some point. And uh, my history in monitoring started with like .NET applications monitoring in a small startup. And then after that, we moved into Microsoft acquired the startup, and we moved there. And I've been working in Microsoft for almost 10 years. And during the time, I went through different stages of monitoring alongside with industry, from proprietary heavy agents and SQL-based backends to big data on a backend and very small open source SDKs for data collection. And part of this journey, I joined OpenTelemetry, and I'm on a governance board and I'm on tech board. I in OpenTelemetry, we had this mission. We understood that everybody, all the vendors, spending so much energy on writing code instrumentation and collecting data that it just hurts an industry. Like everybody have their own SDK to instrument application. They name parameters their own way, and it's not compatible if you have application from multiple sources. And in general, it's just very expensive task with a rapidly developed industry and frameworks and you name it, that we decided that we need to combine forces and do it all together. And now it's my third week started in Google. I switched to Google. I really like working on this vibrant open source community as part of CNCF, and I think Google embraces community very well, and especially in GKE, where Google Kubernetes engine, Kubernetes is biggest, I think, open source community, at least biggest in CNCF. But I think it's huge, it's enormous. I really want to be part of it, so I moved there, and I keep working on OpenTelemetry as my side job, and I think there'll be a lot of connections between what I'm doing in GKE and what I'm doing in OpenTelemetry. And by the end of this discussion, I think I can give a sense why it's so interconnected and why I made the decision to move to Google. But now I'm in Google, I'm learning a lot, and it's an interesting time you caught me in this interview, because I didn't know whether I will move from Microsoft at that time, and I just set a date, and surprisingly, it was after I switched. So yeah, 10 years in Microsoft, and now third week in Google. Yeah, okay. So I have a lot of history in OpenTelemetry and like lots of history in monitoring in general. While OpenTelemetry is a very young project, it just turned 1 year old, and we actually discussing what is the actual birth date of OpenTelemetry. It's somewhere between like 15th of April and maybe 9th of May, somewhere in this range. So it's very young. It's just turned 1 year old, but at the same time, it's a very old project. We have a very long history because history of OpenTelemetry started with two projects that combined from. It's Open Census and Open Tracing. These two projects was developed kind of independently, but I mean, they have a lot of interconnections historically, and like over time, they've been looking at each other. And at some point, we decided we need to just merge those two together and take all the goodness of OpenTelemetry, Open Tracing API, and how it's been presented and how it's kind of satisfy the needs of many library writers and application owners, and Open Census, where it has a very good implementation, very like solid base, because it's coming from Google Census, which is heavily used in Google internally. So the solid base and the high performance, very well written SDK, and we combine it with a very good API, and together, OpenTelemetry, I think it's the best we could come up with plus, we had a very vibrant community since all the members of OpenTracing and OpenCensus came together. We have a lot of people working on the project. Like just sharing some numbers, we became a second most contributed project in CNCF. If you take in last 90 days, so I think it's a big achievement for such a young project. But again, even though the project is young and we just entered beta on Many 6, it's still has a long history and has a great background. So I'm not surprised by this activity, but it's kind of great achievement. I really enjoy it. So, by the way, have you looked at OpenTelemetry? Have you tried to contribute?
I have looked into it, but I haven't tried to contribute.
Okay. So that said, like I just gave a little bit of introduction. Now, what's the future of monitoring? There is a Gartner Magic Quadrant. I'm not sure if you have heard about Gartner. It's a analytical company. They publish in a quadrant of companies in different spaces, specifically for OpenTelemetry. APM space is very well interested. APM stands for Application Performance Management. So they publish quadrants. Quadrants is in the quadrant they place in all the players in this space in a axis, like how much this company how good this company execute and how much it innovates. And based on this quadrant, people can make a decision which vendor to go with or where industry is going to. So they published APM Magic Quadrant recently in April, and they started it by saying that all the majority of cloud native applications will use vendor neutral instrumentation to collect data by 2025, and it's a good prognosis, and it put OpenTelemetry in a very good place, because OpenTelemetry is already backed by many APM vendor and end users, so we have a good story here, and OpenTelemetry is based on standards, and we participate in activities like Kubernetes SIG instrumentation or CNCF observability SIG. So we're part of all those initiatives, and OpenTelemetry, I'm pretty sure OpenTelemetry will be that force that will move all the cloud native applications into being more manageable and more transparent for end user. So yeah, we believe in this notion that all the applications are instrumented out of the box, and hopefully at some point all you will need to do is when you're looking at OpenTelemetry is just instrument enabling this instrumentation that already exists in the application and tell where to send this data. So in this example, I just pasted something from C# OpenTelemetry SDK. You configure Zipkin endpoint saying like, please take all the telemetry and send it to this Zipkin endpoint. And I'm also saying which instrumentation to enable. In this example, I want request telemetry, like incoming requests to be monitored and all the outgoing calls to be instrumented. So it's quite easy. Like I don't need to tell how to instrument and like whether I need to start span, end span, or whether I need to like log some duration of execution. I just enable it and just saying, please turn on all the instrumentation that already exists in the application. Let me turn off the light sound here. By the way, I have this T-shirt, OpenTelemetry Alpha contributor.
Nice.
So yeah, this is a grand vision. We want to get to the stage where you simply enable instrumentation and you get all the goodness of it. You said you played with it. Have you tried it? Like, which language you tried OpenTelemetry with?
Tried with Go. That's my main language. backend.
Why I'm not surprised? Yeah, okay.
You're more
Go
of a
is great.
C# guy?
I came from Microsoft, and I'm currently maintainer of .NET SIG. I like Go. I'm learning it right now, and it's I mean I'm learning it more deeply than before.
Okay.
So, yeah. Interesting thing about Go is that in Go there is less of that monkey patching or like kind of secret instrumentation, like hooking something into telemetry. That's why in Go it's even more important to have libraries and platforms to be pre-instrumented with OpenTelemetry. So you have, let's say, you have a library to talk to. I wouldn't give examples because I don't know the current state, but I think like if you have some backend service and you have a library talking to the backend service, and you want to tell end user how this library behaves and how this backend service behaves, you may want to expose this information, and the best way to expose it is just add OpenTelemetry hooks, saying like I started calling into my backend service, I ended calling into my backend service, and OpenTelemetry will automatically calculate time and collect extra parameters for you. So in Go, it's especially important because there is no monkey patching. Like you cannot just say, oh, I have this client library, I just like patch it into like as a JavaScript. Like I can just insert callbacks in the begin and end of this function and like wrap it around, and this will be my this is how I calculate time of calling into my backend service. Instead, the backend service needs to expose those callbacks, and it makes OpenTelemetry even more valuable, and OpenTelemetry API that needs to be very well optimized for that kind of use. That leads me into the next topic. I copied from one of the blog posts from before. So basically, I just mentioned that if you want to expose information about your backend service, how it operates, how it works, you need to call into some API, and this API package is supposed to be very narrow and small, so nobody will have a problem taking dependency on it. Ideally, this API surface shouldn't have any implementation inside, so it should be just like it should only allow to take signals like start of operation, end of operation, specific attribute was created, or specific event happened during the execution of your operation. That kind of signals that API should accept. And ideally, if there is nobody listening for the signals, it should be no op. It should be like transparent for application and do nothing. We have this pre-instrumented libraries in some languages, and I'm really proud what we did in .NET. Is in .NET, this instrumentation already built in many applications. So if you take like latest version of ASP.NET core applications, they already exposing these callbacks automatically. So by default, they do nothing, but if you enable them, you can immediately get this information. Plus, it has context propagation from one node to another, also implemented automatically. So by mere like having API inside your application, and in the case of .NET, it's already built in, you get all the callbacks and all the basic functionality working. And then to enable it, you just install SDK and say like enable these callbacks. And this SDK will react on the signals from API and start building up the span information, like associating with attributes and sending it to processing layer. Then processing layer is something that you can configure to attribute your telemetry with additional information, or maybe you want to filter some subset of your spans. Perhaps you can do some other complicated logic. It's very highly optimized. So you can hook into this processing logic and do some manipulation of your telemetry. And finally, it reaches exporters. An exporter takes all the telemetry that you just massaged with the processing layer and try to ship it to the backend. It can ship it directly to the backend, or it can go through OpenTelemetry collector, and collector in this case something that deployed outside of process, and if you ship it to collectors, and collector can upload further to backend of your choice. And the good thing about collector is that it stands outside of your application, and it can be vendor neutral. So you can get a collector installed and then switch a backend to send you telemetry to in a collector rather than inside the application itself. So application wouldn't change, but on a backend, on a configuration layer, on a control plane, you can reroute your telemetry into different backend, and this way you can control like how much telemetry you want in your backend, or you will be free to switch from one proprietary backend to another proprietary backend, or you can work in different modes, like offline mode with locally installed instance of Jager, or in an online mode in sending data to backend like Stackdriver or something. So yeah, this is quite powerful and quite flexible architecture here with many extensibility layers. But again, ideally, most of the people will need to just enable OpenTelemetry, and I showed here it's quite invasive here, so you need to write like 4 lines of code. It's a lot. For my taste, ideally it should be 0, or maybe like just environment variables that you set, and environment variable, you set an environment variable, and suddenly you have all this goodness of monitoring, and then maybe in a control plane, you configure collector to send data to the backend of your choice. And I know this is a Kubernetes podcast. Do you call your show podcast? Okay. Okay. Or maybe a show. Okay. I will call it a podcast if you don't mind. I mean, you tell me. Yeah.
Sure, it's okay.
So yeah. So I know this is a Kubernetes podcast. That's why I didn't want to show some specifics, like many OpenTelemetry getting started guides that you can find on the internet. They're basically saying, you know, there's architecture and this is how you enable, and then they walk you through step by step, like concepts like span. What is span? And in this case, span is like incoming request. I don't know if you see it very well, but this is like client app, and it has a span with a duration of 352 milliseconds, and it's like that long. It's visualized here, so it's kind of part of execution of your application. And then typically getting started guide goes into this is how API looks like, how you can start span, end span. Maybe this is how you do metrics of spans, or maybe how you count some purchases in your application, or maybe some telemetry, like other telemetry, like incoming request size telemetry. Maybe you want to calculate this metric. I don't want to go into these details because I think this is Kubernetes show, and I want to concentrate on how OpenTelemetry, given that data is already collected, can help you control how this data being processed and where this data being uploaded. And I want to tell you an interesting story about it, and it's a little bit of history that when I was working in this startup, it was called Avicode, and Microsoft decided to acquire it. They sent few people to Russia. Startup was based, like development was based in Russia, so they sent a few people from Microsoft main office to Russia to interview us. And I was having this interview. I was already very deep into monitoring space, and I knew how to inject code into .NET applications, how to process data, and how to collect very interesting data out of like massive amount of signals. I wanted to I was able to filter these signals and extract the most valuable information. And I was very much into that kind of notion of how to collect good telemetry, how to collect proper telemetry, and how to satisfy user on that space. And during the interview, interviewer, he was asking many questions about monitoring, but all his questions was about pipeline of telemetry. Like I remember this discussion. We've been talking about metrics and a high volume of metrics flowing through agent, and agent start delaying upload of this metrics to the backend, and how agent needs to react, how it needs to put back pressure to application that produces data, or maybe how it can start aggregating data and sending like aggregates into backend. So all the questions was about processing data, and very little, if none, were about data quality. And I was shocked. I mean, it was such a different space for me, because I was mostly concerned about quality telemetry to be uploaded, and then like once this telemetry exists, it's for me it was kind of no-brainer. I mean, there is an easy way to upload it. Like, I mean, easy. For me, it was that part wasn't that exciting and that close to our customers. So I was surprised by that questions, and then I learned that the team that I joined, it's called System Center Operation Manager. This team was tasked to create an infrastructure for monitoring, and all the actual data collection was developed by end users. Like we had a managed pack. Managed pack is a declarative configuration of what to monitor out of environment. And there was a managed pack for Exchange, for instance. And this managed pack was authored by Exchange team, because they are experts on how to monitor Exchange. They're experts in which metrics to collect, which logs to upload, and when what condition means that Exchange is in a critical state or like pre-critical state and needs to take care of. And the team was offloaded this task of creating managed packs to the teams owning the infrastructure, and their main job was to efficiently deliver this telemetry to the backend and present it to customers. So basically creating infrastructure. And I was mostly concerned about data quality and how to collect data from applications. So that was eye-opener for me, that there are environments and there are like ways to make sure that the application itself, in this case, like Exchange or maybe SQL Server, expose all the telemetry, and your only job as a monitoring system is to upload this telemetry and save it. Unfortunately, at that time, there was nothing like that for regular user space applications. So all the user space applications had inconsistent telemetry sources. They had inconsistent type of exposure metrics or information about distributed traces. I mean, even logs was differently produced. Some application or some components of application were producing ETW logs, some producing logs in the form of files, and some were using some other mechanisms. And it was very strange combination that required us to go deep and understand the application like to go and invest in the quality of data that's produced, and spend less time on how efficiently to upload this data and how to process this data efficiently. With OpenTelemetry, this changes. With OpenTelemetry, from that situation when you need to really understand how application works and what telemetry it exposes, you switch it into more than application already produces data that can be understood by users, that can be like unifiedly processed, and your only job is to take this data and upload it to the backend. That's why collector, like OpenTelemetry collector, became a big deal here. And I have this. By the way, did it blog the picture? Okay, maybe this one better. So yeah, so that's why collector became a big deal for OpenTelemetry. Since we unified the signal that application produce, we unified which telemetry we collect. We can start concentrating on how we process this data and what we can do with this data. And that's why OpenTelemetry collector is a big deal, and it's a part of our project. So OpenTelemetry collector allows you to receive data from multiple sources. In this case, like I wrote few, but I think there are many more receivers of telemetry now. And then it allows to do some manipulation of this data, including batching or like filtering, sampling, maybe attributing with different telemetry, and then send it to multiple backends. And we have so many exporters configured already that just it became a central point which you can configure and send all your telemetry through. We have Jager, Stackdriver, Azure Monitor, like many of them. In any case, so this is a collector, and one interesting thing you can see here that OpenTelemetry collector can receive data from OpenTelemetry SDK in the form of like OpenTelemetry proto files, and send it back to OpenTelemetry as OpenTelemetry proto files. And the reason we need it is that we want to support chaining of collectors. And chaining of collectors is very important for scenarios when you want to not only configure central like location for collecting your data, but also you want to proxy this collection and have certain collectors co-located with your application and making initial filtering or data manipulation, and then sending the data to central collectors that will forward it further to the backend of your choice. So we can look at it a little bit more details now. Expand it. Yeah. Let's go here. Do you have any questions so far? I feel that I'm talking so much, and I want some feedback. Yeah. Okay.
So far, so good. Someone saying he's planning to use it with Java. So.
Do you mean did you comment somebody asking about Java?
No, when you ask if I tried it and with what language, I said Go, and someone said he's using it with Java.
Oh, cool. Okay.
But just a comment.
Yeah. So yeah, I think Go is the most mature SDK in OpenTelemetry. So Java maybe on the second place.
I saw that with Java you have some spatial agent stuff available, and you don't have that with Go. Is that?
Yeah, with Java
it's not possible with Go because it's static. It's you cannot monkey patch, as you say, or.
Yeah. So in Java, we have two repositories. One is just pure SDK, and this SDK will come with some like modules to instrument well-known platforms like Spring Boot or something like that. And with Java, we also want to support injection of code into like bytecode manipulations. That's why Java auto instrumentation is a big deal, and it's the only code injection mechanism that went into beta with all other SDKs. So we want to have code injection with other languages, but Java is most advanced at the moment. So yeah, Java auto instrumentation is a big deal.
You think we'll have this with Go also, auto injection?
I don't think so. I know that some vendors have a way to inject code into Go applications, and I heard people bragging about it, saying like they figured out a way to do that, but I don't think language itself supports it very well.
Yeah.
So we'll see. It's interesting how auto instrumentation is again coming back to what you want to know about OpenTelemetry, and if you managing your infrastructure, you probably want to know about how to configure, like how to enable it and how to configure it to send data to the proper location, right? So it's two pieces of information you need as a minimum. And if you need to go and rebuild your application to inject a few lines of code, it's kind of already too much. You don't want it just to try it out, and not all the time it's that easy to rebuild your application with like process-wide. Like maybe you don't want you don't have a mechanism to test it, or like to flight it with your test environment. So like auto instrumentation solves this problem because you don't like it allows you to instrument application without going back to code and recompiling it. So basically, just installing extra components that will inject code inside your application. So it's a very good way to get started with OpenTelemetry and with telemetry in general. On the dark side, it's something that relatively hard to test and control because if it's only controlled by control plane, so you don't version your application with a version of agent, then agent may collect telemetry that you don't expect. So let's say you updated the version of agent and it started producing different type of telemetry, or you updated your application and it started behaving a little bit differently, and agent now cannot instrument your application. Let's say we have MongoDB auto injection in Java, and you updated version of MongoDB driver in your application, and Java auto instrumentation suddenly cannot inject code in this driver because it just don't know about this updated version. So you suddenly lost all the telemetry, and you have very limited way to test it before you go to production. So that is a trade-off that you need to go with. But again, auto instrumentation is a kind of big deal for getting started. Yeah. Anyway, yeah. So coming back to this situation when with the collector and how collector can be used and configured. Yeah, I mean, if you want to get started with collector, you can go, like, there are many getting started examples on OpenTelemetry.io. This specific example for collector is very simple. Interestingly, it uses Go SDK to instrument application, so it has a very basic Go application. And there is a snippet from this example. It's saying that example provides a YAML file to configure your application, to configure OpenTelemetry collector as both daemon set for every host, so it's kind of agent installation on every host, and collector, central collector that aggregates data from all the agents and can be configured to send data to many backends. And in the example that's given in this getting started guide, it goes into Jager. So this is kind of interesting concept that is already implemented in this getting started guide that we give out of the box. Like by default, like the first guide you want to follow is that guide that gives this similarly complicated architecture. And like this, yeah, this architecture looks like that. Move it maybe here. So in this example, you see OpenTelemetry. These black boxes are actually the same component. It's just called differently. In this case, it's called OpenTelemetry agent, and in this case, it's called OpenTelemetry collector. The only difference between those two is, I mean, maybe there are two differences. So typically, you will go for agents, you will allocate less memory and less resources in general. So you want to, like, these agents are typically only pass through collectors. So you send data to this agent, and this agent is maybe enriches data a little bit, or maybe applies some filtering logic, but it doesn't do much of buffering or batching or like any sort of complicated sampling mechanisms that you like one example is retroactive sampling. It doesn't do all this complicated mechanisms. It just offload this complicated mechanisms to central collector that maybe deploy to one per cluster, and this collector will do all the complicated logic of doing retroactive sampling or doing like very efficient upload with batching and retries to all those backends. So this architecture allows you to first have a very, another good thing about this architecture is that when your application, like in this case it's called service, if your service crashes, since collector was located very close to the service, it probably already sent all the telemetry about this crash to the agent. And even though service is crashed, you already have information about crash in this agent, so it has more reliability. And this information will be uploaded to collector, and you will be able to troubleshoot this crash. When if you have different architecture and service goes directly to Jager or directly to some other backend, in these cases you will get problem. Like typically for this kind of upload, you want to optimize it and you want to like batch big amount of data together. And if your application starts crashing, you probably don't have time to batch all this data, and you may not be able to upload this data, so you wouldn't get information about this crash on your backend. So yeah, and this is a typical architecture that you probably will go through. Sometimes you want to change this architecture, and sometimes you may want to go into like the situation. Like let's say your application already instrumented with the Jager SDK, and you don't want to change your application instrumentation just because you want to switch to OpenTelemetry. You can start gradually. You can switch one service to OpenTelemetry and keep using Jager in other service. You can just proxy all this data through the same collector, and it will go to central place. And you like on the collector side, you wouldn't even recognize which telemetry came from Jager SDK and which telemetry came from OpenTelemetry SDK, so it will all be transparent. Also, this architecture, like what you can also do, and again, this is this architecture allows you to control all the aspects of your pipeline of how you upload telemetry through the control plane. So you, in your Kubernetes cluster, you're saying, I want this agent to be deployed on every single host as a daemon set, and I want to have a collector here, and I want to configure my service that uses Jager API or Jager SDK to send data to this port and to this application on this port, and it will go through OpenTelemetry agent and into here. So you don't even need to re-instrument your service. You just need to specify new address for your backend, and you all set. You have all telemetry flowing very naturally. Same here with OpenTelemetry. Once you instrumented OpenTelemetry, you don't need to configure OpenTelemetry and tell OpenTelemetry where to send telemetry, like which backend to send telemetry to, or like how you want to optimize this upload. You don't want to, like, you don't need to specify how much batch support you want, how much sampling you want to apply. You just send all telemetry to this agent, and this telemetry will be and the flow of this telemetry can be controlled through the control plane. So on agent, you can do filtering or sampling, and then more complicated logic can be done on OpenTelemetry collector, and there is a single place where you configure the backend of your choice. So again, it's like you moving concern of application monitoring from what data to collect and how to instrument the application into how you control the flow of this telemetry through your cluster, through your pipeline. So you control sampling and filtering and all the like backend configuration, but you don't go into controlling how applications is instrumented on which telemetry to produce. So telemetry is already being produced, and it's already high quality. So you care about what telemetry, like what subset of this telemetry you want, rather than how to get this telemetry out of application in the first place. You can, does it make sense? Does it make sense like how, like, with the OpenTelemetry, I mean, yeah, I was joking all the time, and I keep doing it. So in OpenTelemetry, I see myself as working on eliminating my job. So I've been in business of doing a great monitoring, like great quality telemetry produced by application for a very long time. And then with OpenTelemetry, this telemetry, this high quality telemetry being produced automatically by every single component. So I don't need to learn about those components. I just need to know what to expect from this, like which format this telemetry should be expected, and know how to send telemetry to the backend. And I kind of like with OpenTelemetry, I kind of eliminating the need of me going and instrumenting all these libraries and extracting telemetry out of it. So I was joking that I'm working on eliminating my job out of existence.
Nice.
So yeah, and with this elimination, like you have high quality telemetry data, all you need to do is to understand how to tweak this data and how to process this data, and you have a great tools in the form of OpenTelemetry collector to do this manipulation. I think a lot of competition across many vendors will be in this space. We already have many APM vendors trying to do no sampling approach, or trying to store some subset of data of telemetry locally to the cluster and then access it on demand, or doing some post-processing of this telemetry. So we have competition moving from what data to collect, and I call it checkbox war. Like checkbox war is when vendors competing on how many libraries that can extract information from. So like, let's say vendor A saying, I can support 5 programming languages, and in every programming languages I can support like MongoDB drivers. And another vendor saying, I support 6 programming languages, but I cannot do Mongo, but I can do SQL very well. And this is kind of checkbox war. Everybody produces a checkbox, and like when end user coming and picking a tool to play with, they just comparing their set of technologies with this checkbox list and picking the vendor that supports the most of their checkbox. We're moving from checkbox wars with OpenTelemetry into competition on telemetry processing. And I think a lot of competition will be on the backend, how data being aggregated and like processed, and what insights from this data can be shown to user. So basically, doing analysis of the data on the backend and producing some interesting insights for customers to react on. And part of this competition would be on pipeline level. Today, we provide a lot of knobs, like what you can configure on OpenTelemetry and agent and OpenTelemetry collector. Later, I think we may see some pre-configured pipelines, like pipeline that are optimized for no sampling approach, where you have all the data available, maybe just compressed very efficiently, or maybe it's stored in some scratch place that is very cheap. Or maybe competitors will be doing analysis, this like high throughput data analysis on a cluster rather than a backend. So you have you can analyze all the data rather than a subset of data that you can afford yourself to upload to the cloud. So this competition will be there. And that's what OpenTelemetry is doing.
How far do you think intelligent sampling can go? Do you think the users still need to configure what is it they want to send to the collector?
For sampling specifically?
Yeah.
It's interesting. I think so. Sampling can be done on many layers. The best sampling is no sampling, because you have all the information you have, all the information. So if you have all the information about your servers, and you can do all sorts of insights and all sorts of analysis, and it's kind of the best situation. But then you go into this problem when I was trying to explain sampling and why it's important. I was giving an example of our backend that will be implemented to accept data about this accept this monitoring data. So let's say you're sending data to the backend, to the front-end service, that like ingress point of your backend. And this ingress point accepts all the data about your application, how application behaves. And then let's say you want to monitor this ingress server itself. In order to monitor ingress service itself, you need to produce a telemetry item, telemetry information about every single incoming ingress point. So you basically double all the telemetry about your you double all the telemetry, all the information that coming from your system. So you have all the monitoring data from your client, and then you, for every single incoming request to your ingress service, you want to produce another telemetry item about this ingress service. And if you use the same backend, you need to do this again. So you go into this infinite recursion that you cannot stop producing data. You always are producing data about that represents data that was just ingressed into your backend. That's why you always need sampling. Like sampling is something inevitable. You'll end up implementing sampling on this ingress service. Otherwise, you will be in this infinite loop of producing data about producing data, right? So sampling will be implemented for sure. Now the question is, if you have sampling, where to implement it? And again, you can many applications can afford not sampling data at all and just send all the data to backend. If you just calculate your COGS and you think it's reasonable, you can go with that. I remember there was studies of how many requests per second typical application has, and I don't remember the number, but I think it was around like maybe 1 request per second in average, if you like aggregate across a long period of time. So it's like most of applications are quite has quite little load. Yeah, so you probably afford no sampling approach. But then you enter the higher throughput applications. Like let's say you have like 10 requests per second, and 10 requests per second is something that it's not that easy to not sample, because you end up producing a lot of telemetry. So you want to start sampling this application. It's not that much load that you cannot collect this information. It's just too expensive to upload it all the way to the backend because of storage mechanism. And in this case, if you're in this situation when it's not that expensive to produce telemetry, but it's very expensive to move this telemetry around, you may opt out into producing this telemetry anyway and sending it to maybe some OpenTelemetry collector that is co-located to your application. It's very cheap. It's almost no network there. And then apply sampling on the collector side. This will give you a lot of flexibility of post-configuring sampling the way you like. Let's say you made a mistake and you sample too aggressively, or you have some incident and you really want all information about your application right now. Instead of going to every single instance of your application deploy it and reconfigure sampling there, you can just go to the central place, central collector, and configure different sampling arguments in this place, and the collector will change it in runtime without restart of any service. So you get like you get a benefit of reconfiguration, like almost instant reconfiguration without restarting the service itself. So you can catch a problem if you experience a problem, or you can you wouldn't interrupt production with that kind of sampling configuration change. Plus, collector, if it receives all the telemetry, it can start doing some analysis on this telemetry that wasn't available before. So one of the analyses we like to talk about is retroactive sampling. So typically sampling is like classical sampling is statistical sampling, probabilistic sampling, when you take one request out of 1,000 or out of like 10 and only send information about this request. And you don't care about what the content of this request. You're just saying that just from probability perspective, if this request had a problem, you will have another request having the same problem, and that another wouldn't be sampled in one of the 10 cases, right? So you will get the instance of this problem anyway. With the retroactive sampling, since you have all the information, you can start buffering this information and saying, if this distributed trace has an error, which is a good indication that this may be interesting for the end user, we will send information about this distributed trace to the backend anyway, even though like it's not supposed to be sampled by a probabilistic algorithm. So you can retroactively analyze what was this trace contained and make a decision of sending information, not sending information when distribute trace ended rather than when distribute trace just started. So that sampling on a collector has this very good benefit here. But when you go from 10 requests per second, I mean, it's just rough numbers. Like if you go into realm of like hundreds requests per second per service per container, then you probably it became too expensive even to collect information about every single incoming request. Not saying like uploading this information even through the very short network from from this host to another host in the same cluster. Even this network became too expensive, and you cannot afford to collect information about your spans. So you need to move sampling all the way to the beginning of request processing. And when request starts, you make a decision of sample or non-sample. And having this decision, you not only eliminating the need to send information about this request to collector, but also eliminating the need to collect information about the request itself. So you don't need to construct like allocate memory for the span object. You don't need to allocate memory for all the attributes belong to the span object. You just do nothing. You just made a decision and then propagate the decision all the way to the distributed trace. And it's basically like one flag that you need to propagate saying like, please don't sample me. That's why sampling can be applied on the very beginning. But again, like the best sampling is no sampling if possible. Sometimes it's just not possible and you need to apply sampling.
Mm-hmm.
Anyway, yeah, and as I said, collector has this good flexibility of how you configure things. And this picture shows that you don't have to have agents if you don't want to. So agents, as a daemon said, is taking resources from every single host. And in some cases, you may not want it. You just don't want to apply any extra logic on every single host. You just want to upload telemetry straight to collector. It has some drawbacks. For instance, you cannot, I mean, you need to process more information on the collector, but at the same time, it simplifies your architecture and having less, it makes you have less failure points. So that architecture may also be applied. And finally, you may not want to have a collector itself, and you can want to take agents uploading data directly to all the backends that you have. And in this case, you eliminate the need of having this central failure point here. Yeah, I think again, and all this configuration and pipeline of collectors is easily configurable through control plane. So you just configure where you deploy collectors and how you configure them, and apply additional rules like how you want the sampling be performed, what extra information you want to collect, and maybe additional sources of telemetry you want to associate with your distributed tracing and metrics telemetry from OpenTelemetry. So that's it. Yeah, I think it's just a copy. That's it. Yeah, I really want for you to get involved, and if you have some feedback on how you tried OpenTelemetry and something worked for you or something didn't work for you, there are many ways to give us this information and communicate to us. And sorry, I took almost an hour of your time. Do we still have time for questions?
Sure, no problem. Give me a second. Okay. So thanks for the talk. That's very interesting. So how many projects now are compatible with the OpenTelemetry already? You know, more or less. I saw Prometheus, Jager, Zipkin. Are you aware of more than those?
You mean from backend perspective?
Yeah, from the backend.
So there are many proprietary backends that are already supported.
I
So
think that Datadog supported. They contributed also to the project.
so um, I'm pretty sure that they were planning to do that, and I'm not sure the current status. So Datadog may be supported on. So every single vendor that joins OpenTelemetry has a way to decide how they want to integrate with OpenTelemetry. Easiest integration is with OpenTelemetry collector. So once you provided the exporter for collector, you can you immediately supported every single language, because every single language can talk to collector, and collector, if collector has a way to upload to your backend, then you immediately support it. I checked yesterday and I don't remember seeing OpenTelemetry Datadog in a list of exporters. So
Do you think some proprietary vendor are afraid of being replaced, as you said, or I guess on the
no,
backend it's not really relevant, but maybe on the exporter collector.
no, it's not that. I don't think anybody afraid of it. Um, it just takes time. OpenTelemetry is still in beta, and nobody can recommend to use OpenTelemetry because on the production, like people can start playing with that and start giving feedback, but there is no product. Like there is really few customers using OpenTelemetry in production, and I think for vendors it's a little bit. It may be a little bit hard to since they cannot recommend to customers, they may not want to jump into implementing expertise right away. I don't think it's a problem or they don't want to. I think it's just timing, resourcing, and like uh, timing and resourcing issue rather than not want to. And I had a lot of conversations with other vendors. I don't think I can talk, like it may have been a little bit more private, but I know that many vendors just waiting to implement it. They just waiting for the right moment to do that and have a maybe have a bigger announcement on for their customers, or align it with some other releases that they planning to. So there is some aspect of timing that they want to leverage. Um, I can tell that I mentioned Gartner APM Quadrant, APM Magic Quadrant report, and Gartner is very clear on which vendors support OpenTelemetry and which is not, and sometimes it even puts this support for OpenTelemetry as a show of strength or show of weakness of specific vendors. I think I think everybody recognizes that OpenTelemetry is a future, and they need to play with OpenTelemetry. So even though there is no Datadog now, or maybe I just cannot find it, there may be it
I
probably
saw
will
a
be
blog
shown
post,
very soon.
but it was a long time ago.
Datadog contributed original version of Java auto instrumentation to OpenTelemetry.
Okay.
So they're definitely involved, and I saw a lot of activity there. That's why I'm saying, like, one way to integrate with OpenTelemetry is a collector. There may be other ways. Maybe they have Java-specific exporter for OpenTelemetry. Yeah, unfortunately,
Okay.
I cannot find the current status now, but
Yeah, no worries. And do you know if it makes sense to directly connect OpenTelemetry to a database like MySQL and send everything that's happening rather than connecting from the code of the application?
do you mean to send telemetry to MySQL?
No, from MySQL, like if I want to send every single queries that are being executed on MySQL, I think it would make sense to connect it directly to MySQL, or it's not really.
Oh, I see what you're asking. So your question is, can instead of monitoring application, can we monitor MySQL itself? Is that the question?
Yeah, instead of sending all my SQL queries that my application execute, could I directly connect it to MySQL log or something?
Yeah,
Does it make
interesting.
sense?
There are pros and cons of this approach. Definitely, when you monitor MySQL or any other database, you can gather more information about query execution than you can get from application itself. So you can ask MySQL for query execution plan, or maybe some details of whether query was cached or not cached. So that kind of information may be interesting for analysis on backend. However,
there's no context.
Yeah, context is different things, but I think context is one drawback of not having context is hard. I mean, I think there are discussions with some SQL providers to start correlating backend SQL queries with a trace context, with a distributed trace context. It's I think it's in the discussion stage. Yeah, I don't know how much commitment there is, but this is something that we're looking at as part of W3C distributed tracing working group. So we want to enable SQL backends to correlate SQL execution, like query execution, with originating distributed trace. So this is one part. But I think bigger part is many database failures are actually network failures. So we see over and again that application start failing to connect to database. Maybe it's a DNS issue, or maybe it's a network glitch that doesn't allow your container to connect to database, and you see it as a failure of your query layer, but you wouldn't see this attempt to do this query on a MySQL side. So on a MySQL side, you will notice that you may miss some queries, like some queries may not reach your application, but you wouldn't know that your distributed trace was broken because we attempted to do this query and failed. So there will be a little bit of disconnect here.
You also mentioned that language like Go, they need good integration because you cannot monkey patch. Do you think adoption will be a bit slower on Go because every library needs to integrate OpenTelemetry? Like not every libraries, but libraries that would benefit from it. They need special implementation.
No, I think in Go specifically, I have a sense. I don't have a data to back me up on that, but I have a sense that people developing on Go are more into cloud native world. So typically deployment of like redeployment of application or this configuration as a code is more natural to developers on Golang than on other languages. So some old languages like Java less there are many Java applications that are not cloud native. There are few Golang applications that are not cloud native. So I would say that if your application is already optimized for cloud and you have an easy way to change code and redeploy or flight some feature, then it will be easier for you to just use OpenTelemetry SDK and try application with this SDK and redeploy it and get your telemetry than on Java. On Java, you'll have more applications that just cannot do that or cannot do it fast enough. So I think just of the nature of user base and these different languages, I think Go wouldn't have any problems with adoption.
Okay. So we have any question from the chat? And I know that so you support very different backends like Prometheus and Jager that have different needs. Has it been complicated to satisfy all these backends that have different needs, or how do you communicate with them?
I didn't quite get a question. What different needs of Jager do you mean?
I guess Prometheus and Jager, they have different features, and maybe they need different things from OpenTelemetry, or is it like uh, is it? It's not a problem. You just need traces.
No, I think if you're talking specifically about Jager, Jager and OpenTelemetry are very uh, close to each other. So since Jager is was developed very close with OpenTracing, and OpenTracing is one of the predecessors of OpenTelemetry, they are very well connected to each other. So yeah, that shouldn't be a problem.
And Prometheus.
We have a issue on specification repository listing all the differences between Jager SDK and implementation in OpenTelemetry, and a few of them, like one of them, I think bigger one is sampling configuration that can be pushed to Jager SDK, and we looking into implementing the same mechanism for OpenTelemetry going forward. So that's one of the missing piece right now. There are a few others, but they're not critical. They're not blockers in any sense. So they're very close to each other. And I think Jager recently announced that they will be switching to OpenTelemetry collector from Jager agent. And Jager agent will basically be OpenTelemetry collector with extra modules deployed on top of it.
Okay, so one last question. You mentioned that many people do not consider it production ready. When do you think it will be stable enough to be recommended everywhere?
So we have few customers who are using it in production. I think we want, like, we need to declare GA for OpenTelemetry. The problem is that we have it's a very hard task to get so many languages aligned and collect all the feedback about all these languages and deliver them in the same time. So I think we're looking into this calendar year for having like very wide adoption, maybe like a KubeCon timeframe for GA everything. Some people more optimistic, saying we will have a GA of at least few languages in summer. Some people more pessimistic, saying like we probably will go into the next year, especially with the quarantine and everything being delayed. But I think the truth is in the middle. So maybe end of year will be the big GA for us. But again, on some languages, like we actually have a very good support. Like Go, on Go, we have few customers. On .NET, I can talk about .NET because I'm a maintainer of the SIG. In .NET, we try to align our schedule with the .NET schedule itself. .NET 5 is scheduled for November, I believe, and .NET 5 will have even more OpenTelemetry features built in, and this is a way for us to, like, if we want to ship these features and align OpenTelemetry SDK with features implemented in .NET, the schedule will probably be the same as .NET schedule. So November-ish, we'll have a stable version of OpenTelemetry in .NET.
Right. Well, thanks for all the great information. It was really nice to have you. Is there anything you would like to add before?
I think, I think OpenTelemetry has this great vision of being built in all the application out of the box, and hopefully, like, I really want to get to this point when everything is like all the telemetry is already produced, and the only thing you need to do is to configure the pipeline of uploading this telemetry. So, this is what I will be looking at going forward with my investment into GKE and like working on GKE full time. So I want to try to understand how Kubernetes can help with this pipeline building and making sure that telemetry flowing seamlessly to the backend of your choice. So I think there will be many more new improvements in how you look at telemetry and how you understand telemetry, and it will greatly simplify the life of all the developers.
All right. Thank you so much. Thanks everyone for watching, and don't forget to subscribe to the channel as usual. And well, see you soon, hopefully.
Thank you. Bye bye.
Cheers, everyone. Bye bye.